My name is Ni'amiz Hakim bin Hassan. This is our group member, Ada Raimi, Muhammad Hamis Hazim, and Muhammad Faris bin Noliki. Okay, let's go to manual calculation about Laplace. Given yt 2 and negative 1, 0, t and 2, t 2. Okay, for the Laplace transform, yt equal 2 plus negative 1, negative 2 h, and t and minus 2. Okay, that calculate yt equal to 2 minus 3h and t minus 2, and Laplace 2 minus Laplace 3h t minus 2. Okay, so for the answer is 2 over 5 minus 3 exponent negative 225 over s.
Assalamualaikum. My name is Amis Azim. I will continue from question A2. So the question asks us to find Laplace transform, which is the Fs are been given. First step, we use a partial fraction, which is A over S plus Bs plus C over S power of 2 plus 10. So second step, we multiply it with denominator of the Fs. So we simplify it and arrange it to general equation. So after we get general equation, we can use a coefficient method to find A and B. So we use a equation from s to the power of 0, s to the power of 1, and s to the power of 2. So we get A is 1 over 2 and B also 1 over 2. So third step is we replace A and B with a value that we have get. So after that, we simplify the equation to make it like ft on the Laplace table. So just refer to the table and we get a final answer 1 over 2 plus 1 over 2 cos 10 the power of 1 over 2 t. So pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Aimi bin Kanul Azmin. My matrix number is AE220029. So I will explain for question B. So the first step is we have to determine the ET. So as shown right here, number one is determine the ET. So this is the equation. How can we determine the ET? Alright, second step. Second step is we have to model the ODE. So for the equation, step number 2 is VL plus VR plus VC is equals to ET bracket. So the equation is shown here. So for the third step, we have to convert the step function of ET in bracket to unit step function. So the equation is here. Then label number 3. For the fourth, we have to substitute the values of R, the values of L, and the values of C. So here we can look. We have done the substitution for R, L, and C. So next. Alright, so for the next slide, I will explain how we get this equation. So to solve the problem, we have to apply Laplace transform. Okay, right here we have done apply the Laplace transform, and we have to substitute the initial condition, that is I 0 in bracket is equals to 0. So we have done here, and then we have to solve for the I s in bracket. So here are the equation for solving that method. Alright, so as you can see, this is the continuation from the previous slide. That is, we have to apply Laplace transform. We have to substitute the initial condition, that is I 0 in bracket is equal to 0, and we have to solve for I s in bracket. Okay. So after we have done all of the steps, we have to use the method of completing the square. So the number 9 here is the step by step how to use the method of completing the square. Alright, so the last step for solving our problem is we have to use the first shift theorem. As you can see, step number 10 is the equation that we are using first shift theorem to get our answer. That's all for me. Thank you.
Assalamualaikum. My name is Muhammad Faris bin Oliki. My matric number is CE220017, and I want to present the simulation for question 4 using the MATLAB code. And for the first question, need to write the equation first using the diagram, which is yt equal to minus 3h t minus 2. And for the MATLAB code, sims function using t and s, and f equal to minus 3 heaviside or h t minus 2, and f equal to Laplace for the function f, t, and s. And after that, we run the code to get the answer, which is the answer is 2 per s minus 3 exponent negative 2 s per s. Next, for the question 2, for the second question, write the equation in the MATLAB code, which is for the function s and t, and fs equal s power of 2 plus 5 divide s multiply s the power of 2 plus 10, and then in the MATLAB f equal I Laplace for the function f, s, and t. And lastly, get the answer for the inverse Laplace transform, which is the answer is cos 10 the power 1 per 2 t per 2 and plus 1 per 2. And for the third question, using the MATLAB, write the coding, which is for the function s and t, and for the resistor value in ohms, which is 0.4, for inductor value equal to 1, capacitor value equal to 8. But in MATLAB, we write the value of capacitor, 8 exponent negative 6, and for the initial current equal to 0, and for the ET equal to 1 minus 1 heaviside t minus 10, and for the ES we Laplace the function of t, ET, and s, and for initial current in the formula Laplace I initial current t and s, and for the ZL equal to R, and for the formula L for the ZL equal to S multiply to L, and for the value of ZC equal to 1 per S multiply C. And for the Z total, ZR plus ZL plus ZC. And for the IS equal to ES, divide Z total plus I0S. And for the IT, we equal to I Laplace, which is inverse Laplace for the IS, S and T. And for the IT equal to VPA, IT, and 4. And the display of the answer for the IT is, and we run the code. And for the IT is 0.002828, exponent negative 0.2t, sine 353.60, minus 0.002828, heavy sides 1t minus 10, exponent 2 minus 0.2t, sine 353.60 minus 3,536. And thank you.